Welcome to Flux Electrical channel. Like, comment and subscribe to the channel to encourage me post more videos on this channel, and get you notified for my next video. Today let's talk about magnet. This is a very crucial tutorial that every electrical engineering and physics student cannot afford to miss. What is magnet? What actually comes to mind whenever magnet is being mentioned? A magnet is an object or material that produces a magnetic field, which can attract or repel certain materials, especially ferromagnetic substances like iron, cobalt and nickel. Magnets work due to the alignment of electron spins in magnetic domains within the material. How does magnet works? It is important to note the keywords from the definition, which are electron spin and magnetic domain. Let's briefly explain these terms. It is crucial to remember that every material is made up of atoms, and every atom is made up of electrons. As these electrons occupy specific orbit in each atom, it has a property called spin, which creates a tiny magnetic moment. Electron spin is a microscopic property of individual electrons. Whenever this electron spin aligns in the same direction within material, the material will possess magnetic property and start to behave like a magnet. The region within a material where the magnetic moment, that is spins of electrons of atoms, are aligned in the same direction is called magnetic domain. In other words, a magnetic domain is a small section of a material where atomic dipoles, that is tiny atomic magnets, group together to form a uniform magnetic field. In magnetic materials, many electron spins align in the same direction, producing a strong overall field. In an unmagnetized material, these domains are randomly arranged and cancel each other out and therefore doesn't possess magnetism. Question: do all materials have magnetic domains? Magnetic domains exist in ferromagnetic materials, like iron, cobalt, and nickel. When an external magnetic field is applied, the domains align in the same direction, creating a strong magnetization. It is important to note now that alignment of electron spin is the fundamental reason why materials exhibit magnetic behavior and also forms poles. Let's talk about this. What are magnetic poles? Magnetic poles are the two regions at the ends of a magnet where the magnetic force is strongest. Every magnet has two poles. North pole N is the end of the magnet that points toward the Earth's north, when freely suspended. South pole S is the end of the magnet that points toward the Earth's south, when freely suspended. Let's look at some properties of magnetic poles. 1. Like poles repel each other. 2. Opposite poles attract each other. 3. Magnetic poles always exist in pairs, meaning you cannot separate a single north or south pole. Even when it is grinded into pieces, each piece still possesses north and south poles. This is known as the principle of magnetic dipoles. 4. The strength of the magnetic field is strongest at the poles. 5. It starts from North Pole and terminates at South Pole, and each magnetic line doesn't cross each other. Magnetic poles are fundamental to magnetism, navigation, and many technological applications. Let's briefly look at types of magnets. 1. Permanent magnets retain their magnetism even after being removed from an external magnetic field. Examples: bar magnets, neodymium magnets. 2. Temporary magnets. This type of magnet becomes magnetized only in the presence of a magnetic field. Examples: soft iron in an electromagnet. 3. Electromagnets. This is created by running an electric current through a coil around a magnetic core. It is a special temporary magnet which most of modern technology depends. Magnets have numerous uses in various fields, including 1. Magnetic lifting devices are tools that use powerful magnets to lift, move, and handle heavy ferrous iron-containing materials without direct physical contact. They are commonly used in industrial, construction, and manufacturing settings to lift steel plates, pipes, scrap metal, and other heavy objects. 2. Magnetic separation is a process used to separate magnetic materials from non-magnetic ones using a magnetic field. It is widely used in industries such as mining, recycling, food processing, and metallurgy. A magnetic separator consists of a magnet or electromagnet that attracts magnetic materials. When a mixture of magnetic and non-magnetic substances is placed in the separator, the magnetic particles are pulled out, while the non-magnetic particles remain. 3. Speakers and microphones convert electrical signals into sound and vice versa. 4. Magnetic resonance imaging. Magnetic resonance imaging (MRI) is a medical imaging technique that uses strong magnetic fields and radio waves to create detailed images of the inside of the body. It is widely used for diagnosing diseases and monitoring medical conditions, especially in the brain, spine, joints, and internal organs. 5. Electric motors and generators use magnets to convert electrical energy into mechanical motion and vice versa. 6. Hard drives and data storage. Older hard drives store data magnetically. 7. Magnetic levitation. Magnetic levitation is a technology that allows objects to float in the air without physical contact by using magnetic forces to counteract gravity. It is commonly used in high-speed trains, experimental transportation systems, and industrial applications. It operates on the principle that like poles repel and opposite poles attract. 8. Electric vehicles. Motors in electric vehicle use strong magnets for efficiency for converting electrical energy to mechanical energy, etc. Magnets play a crucial role in modern technology, industry, and everyday life. If you finds this video, encourage me by comment and subscribing to my YouTube channel to post more videos. Thank you for watching. Bye.